Alright, so today we're going to start using a unit circle, evaluating trig functions on a unit circle. Alright, like I said, do not write anything on there that I do not tell you to write, otherwise they get ripped up on test day. Your unit circle should look something like this, correct?
Yeah.
It has degree measures. Yours actually has the radian measures on it as well. Do you notice, Nate, can I hold this up for a second? So you notice you have the degree measures on the inside. Those things in terms of pi, those are the radian measures for those degrees. So like if I say pi over 3, that's in radians, but it means the same as 60 degrees. So if you were to translate it to degrees or convert it to degrees, pi over 3 would turn into 60 degrees. Alright, so it has radian and degree on there. You'll notice there's x and y values at every single point. So at 150 degrees, I have x, I have y. Right? Do you remember where those x and y values come from, or where all these angles come from? Why do we choose these angles? Special right triangles. Right? So all of these are made from special right triangles, where we would draw in a special right triangle, we'd find how long the x value is, how long the y value is, and that's how we'd find those. Do you need to know how to find them? No. Am I ever going to ask you to do special right triangles to find different places, coordinates on the unit circle? No. But it's nice to know that it does come from special right triangles. Like I said, it came from radius of 1, figuring out what would y and x be based on our different angles, different angle measures, things like that. You don't need to worry about that, right? We're just trying to inform you that that's where this stuff comes from. Okay, it comes from all right triangles, special right triangles. You're never going to be asked to use it, well, not this year at least. And we're not going to ask you to make a unit circle. We're giving you that whole unit circle. We're giving you all those values. Okay, you just got to know how to use this, which is what we're going to learn today. So, if you look on that next page, Leah, can you hold it, back it up? That page with like 16 problems on it. Come on in. Yeah. Right? So, you should all be on that page that Leah just held up, right? Where 16 problems on it. We're not going to do all 16. We're probably going to do about 8 of them. Alright? I'm going to kind of jump around at the start because I want to do the easier ones first, kind of ease us into it. And then we'll start doing some of the harder ones. Alright? So if you look at the top of your unit circle, it's got like sine theta equals y, cosine theta equals x, tangent theta equals y divided by x, so on and so forth. It's got all 6 of our trig functions up there, right? What that means is if I look at, say, 60 degrees, if I look at the x value there, it's 1/2. That means if I took the cosine of 60 degrees, my answer would be 1/2, because cosine is the x value. Right? So it'd be the same as the x value. So that's basically what we're going to do. We're going to take our angle measure, and we're going to take whatever trig function we have, and we're going to try and find it on our unit circle. Okay? So our first problem will be number 1. Unit circle. Oh, it's a trig.
Yeah.
Sorry. So number 1, what does it say?
It says
Cosine of 315. So, cosine on top of our unit circle, first thing I'm going to look at, cosine theta equals what?
X.
X. So, first thing I'm going to do, how I would process this, I'd write x there. Because I know I'm going to be looking for an x value. Well, I'm looking at 315 degrees. Now, I'm going to circle this on my unit circle. You cannot circle it on yours. Right? So at 315 degrees, that means I'm using this one right here. Right? 315 is with this x and y coordinate. Well, which one did I say I was looking for? X or y?
X.
X. So my x coordinate at 315 degrees is square root of 2 over 2. That's my answer. That's it. Right? So the x value at 315 degrees, square root of 2 over 2. That's easy, right? Because we know we're looking for the cosine, which we know is our x value. Okay? Alright, we're going to try number 2. Cosine of negative 210 degrees. Alright. Cosine means I'm looking for x again. On my unit circle, does it have negative degree measures?
No.
No, so I should probably find the positive degree measure for negative 210. How did we say we did it up here? We took 360 and we subtracted it. So I'm going to take 360
What?
minus 210.
Why are you doing that?
Because remember, if I go 210 degrees negative, I want to find out what that positive value is going to be. So to do it, the whole thing's a circle. If I subtract the negative value off, I'm left with the positive. So 360 minus 210 should give me my positive angle measure, which should be 150 degrees. So I'm looking at 150 degrees now, positive 150. I want the x value. Well, the x value is negative square root of 3 over 2. That's my answer. Now, if ever you're given a negative angle measure and you try and change it so you can find the positive angle measure, and you get a number that's not on the unit circle, do you think we would do that to you?
No.
No. Go back and check your work, because we're not going to give you any number that's not on the unit circle. Same thing with radians. If we give it to you in radians and you want to change to degrees, if you get a degree measure that's not on there, we won't do that to you. Alright? It will always be on the unit circle. We'll always give you some sort of angle measure that's on the unit circle. Yes, Ashley?
Why is there two, like, things, like, which one, like, the negative square root of 3 over 2 and then the 1/2?
Because this is an x value, so this is what our cosine will equal at 150. But if we ask you for sine of 150, then it would be the y value here.
Okay.
So that would equal 1/2, alright? We're actually going to do one of those now. We're going to do number 6 next, so sine of 225.
What's that number 3? Yeah, can you...
I told you we're going to kind of skip around.
Oh, I'm confused.
We're gonna,
Why did you subtract 360 from that?
because the whole thing is 360, right?
Yeah.
So if I subtract this negative part off,
Why would you do that though?
because I want the positive angle measure. If I look on here, do I have negative angle measures on here?
No.
No. Or you think of it like you're starting at 360 and you're subtracting 210 and you get 150. Okay? Alright, so the next one we're going to do is sine of 225. If you look on top of your unit circle, it says sine theta equals what? Y. So I'm looking for a y value, and I'm looking at 225 degrees. So 225 degrees is right here. What is my y value there?
Negative, it doesn't matter. It's the same.
I have a y value right here.
Negative square root of 2 over 2.
Negative square root of 2 over 2. That's my answer. Yes, cosine and sine are super easy. Right, they're super easy. And let's try one more like that. Let's try number 12. Try number 12. Cosine of 5 pi over 3. So, looking for an x value, because it's cosine, looking for an x value, 5 pi over 3. How many of us know where 5 pi over 3 is?
Right to the 3 thing.
Let's turn to degree.
It's right there on our unit circle, right? Do I need to change it to degrees?
No.
No. If it's on your unit circle, right, it says it right here. 5 pi over 3. You don't need to change it to degrees. Now, if you still want to, you're more than welcome to. If we ever give you like 8 pi over 3, and that's not on there, then you can change it to degrees and find it. But if it's on there, just use that radian, right? What is my x value at 300 degrees, or 5 pi over 3? 1/2. So my answer would be 1/2. Right? 5 pi over 3 is right here. Alright? Any questions so far? Alright, we've done sine, we've done cosine. Those are the easy ones. Let's try some of the other problems. Now, let's go back to number 3. You guys are all worried about it. We'll go back to number 3.
Yes, it is.
Cosecant of negative 240 degrees. Okay, cosecant theta on top of our unit circle is equal to what in terms of x and y?
1 over y.
1 over y. Okay, 1 over y. Negative 240 degrees. once again, we don't have negative values. You could start at 360, like I just told Alexis, and you could subtract 240 off, and it'll end up putting you at 120. That's the same as doing 360 minus 240. Right? 360 minus 240, because I want the positive angle measure. I get 120 degrees. So cosecant at 120 degrees. Well, is there a spot in there that says that's like 1 over y?
No.
No. So what we're going to do is find that value that's on the bottom. What does y equal at 120 degrees? Well, square root of 3 over 2. Is it fair to say that y is the same as y over 1?
Yes.
Do we all agree that this is the same as this?
Yes.
Y is the same as y over 1? Okay. So we're going to flip it. Take the reciprocal. So we want 1 over y. So 1 over y equals, and I got to take the reciprocal of this one too. 2 over square root of 3. Do not put a box around it yet. It's not a good answer. Not reduce, different R word. Different R word. So it's an R-A.
Radical.
R-A-T.
Ration.
You're really close.
Rational.
Radicals.
Rationalize it, right? Remember, hey, we cannot have a square root in our denominator for our answer. So we multiply top and bottom by square root of 3.
What?
Right? We rationalized last unit. We can't have a square root in our denominator for an answer. So you multiply by the radical in the denominator. So 1 over y now equals 2 square roots of 3 over 3. Right? Square root of 3 times square root of 3 is square root of 9. And the square root of 9 is 3. So my answer then is 2 square roots of 3 over 3. So if you end up with a radical in your denominator, you need to rationalize it. Right? You can't just leave that square root down there or it'll get marked wrong.
What?
Questions so far?
Not really.
No? Alright, let's do 4 next.
That makes
Well, keep going
no sense. Doesn't make sense.
Tangent. Tangent theta is y over x, right? Hold on a second. I'm going to write it as y divided by x. And I'm going to change this one to x divided by y. You can put that on your unit circle if you want. Because that's how I'm going to write it out in my examples. So you can do, instead of y divided by x like this, write it out like this. And for cotangent, instead of x divided by y up and down, x divided by y on its side like that. Right? Because that's how I'm going to do it, because it's going to make sense in a second. Okay? So tangent, we said it was y divided by x. Right? We all agree with that. We all see where that comes from.
What?
And I'm looking at 210 degrees. So here at 210 degrees, what is my y value? Negative 1/2. Divided by, what is my x value? Negative square root of 3 over 2. Hey guys, can I divide by a fraction? No. Keep, change, flip, or multiply by the reciprocal. Right? So keep negative 1/2, change division to multiplication, flip your second one, negative 2 over square root of 3. Right? That's why I wrote it out like this, so we're not writing fraction on top of fraction. Alright? So, multiply your tops. Negative 1 times negative 2. Positive 2. 2 times square root of 3. 2 square roots of 3. There are 2 things we need to do before we have a good answer. What are they? 2 things. Rationalize one of them. What's the other one?
Simplify.
Simplify, right? I'm going to simplify first. 2 over 2. That's the same as 1, right? So they turn into 1s. I get 1 over square root of 3. That square root of 3 does not just magically float up to the numerator. It's still in our denominator. Okay, so we simplified. Now we need to rationalize. So we're going to multiply top and bottom by square root of 3. 1 times square root of 3 is just square root of 3. Square root of 3 times square root of 3 turns into 3. That's my final answer. Okay? Any questions?
33.
33.
Yep.
We are going to do number 9 next. Because that's the only one we haven't done. We've done secant, we've done cosecant, we've done... Did we do secant already?
No.
We didn't?
No.
Okay, so let's do 5 first then. Let's do 5.
Ugh.
Secant of 780 degrees. Alright, so the secant is what in terms of x and y on top of our unit circle? 1 over x. Okay, 780 degrees. Is that on my unit circle?
No.
Why not?
Too big.
It's too big, right? So if I go around once, that would be 360. So I'm going to take that off. I'm left with 420 degrees. Is that on my unit circle?
No.
No. Go around again. Minus 360. I'm left with 60 degrees. So that's what I'm going to look at. Looking at 60 degrees. Well, like I said before, they don't have 1 over x. But I can look and see what does x equal? 1/2. Well, x is the same as x over 1. So then take the reciprocals. So if x over 1 equals 1/2, 1 over x has to equal 2 over 1, or 2. And that's our final answer. Right? There's no simplifying I need to do. I don't need to rationalize. So that's just my final answer.
Wait, why do you flip them?
Because I don't want x, I want to find 1 over x. So I got to take the reciprocals to get 1 over x.
Should we do 16?
We do 16. Sure, we can do that one. Let's do 16 quick, and that'll be the last one we have to do.
How about all these big ones?
We're gonna, well, 9 is a cotangent problem, and so is 16. So I'm just gonna switch those. So instead of doing 9, we'll do 16. Because that one's actually a good problem, because it has negative 13 pi over 4. Negative 13 pi over 4. Well, is that on our unit circle?
No.
So we should probably change it to degrees, right? Remember, to change to degrees, we multiply by 180 over pi. Negative 13 times 180 divided by 4 is? Negative what?
585.
85? Negative 585 degrees. Okay? Cotangent. Cotangent is x divided by y. Well, negative 585. Might be able to figure that out?
Yeah.
No, it's too big, right? So let's take 360 off of it. So that's going to leave me with negative 225 degrees. Well, negative 225, I can figure out the positive angle measure for that, right? I can do 360 minus 225, and I should get 135 degrees. So I know that's where I'm going to be looking, is 135 degrees. At 135 degrees, it says I want x divided by y. Well, what's my x value there? Negative square root of 2 over 2. Divided by, what's my y value?
Square root of 2 over 2.
Okay.
Wait,
All right.
why can't you just look at 225?
Because that's not the same. Right? That's negative 225. So I'd be like going from here down 225.
Oh, okay.
Right? Alright, so keep change flip. Negative square root of 2 over 2 times 2 over square root of 2. Keep change flip, multiply by the reciprocal. We get negative 2 square roots of 2 over 2 square roots of 2.
Wait, what?
right?
It's one.
It's not 1, but it's negative 1,
Same thing.
right? The 2's cancel, the square root of 2's cancel. I'm left with a bunch of 1s. So negative 1's my answer. All right? Does that make sense? All right.
Yes.
Question?